So now I want to take a minute and show you this last new tool. And again, we're seeing, in this case, we have oh, here it is, right? 1 3/5 times 2 1/5. And we can change, we can change those, but I'll show you. I want you to see how this understanding multiplication as area, right? The space that's being taken up. I hope this looks really familiar, right? The idea of a grid, the idea of breaking into these equal pieces and finding what's the space that's in there. Because that's how we can transfer multiplication of whole numbers, especially double digit numbers, to multiplication of mixed numbers. And you'll see soon even decimals. And so what I want you to see here is this is 1 3/5, right? Up here on this dimension, right? This is 1, and this is my 1, 2, 3, right? This is my 3/5. So 1 plus 3/5 here. And now this is 1 whole, 2 wholes. So another 1 whole, another 1 whole, and this is now my 1/5. And if, say, we didn't want them to both be the same, we can change denominator too right here, right? Use the slider. Maybe we want it to be fourths. So here, now we can do, oh, now it's 3/4. Sure. Let's try that one. So what I want you to see is the area that's being taken up is, right, the same idea that we've been doing with open arrays. 1 times 1, right? This is 1 whole. Another 1 and another 1, 1 whole. And now we see 1, oopsie, times 1/5, 2/5, 3/5, right? So this space right here is 3/5. Another 1 times 3/5. And now here we have a 1 whole, and this is my 3/4. So this is 3/4. And now we have the 3/5, right, going horizontally, and then the 3/4. So that's what we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This is 9. And then how many is in this whole square, right? One of these big green, the outline in green is the whole. So this is 9/20. And you can see how each of these wholes, right, is broken up into 20 pieces. And so just like we did with the set model, right, when we talked about defining the whole, as rows and columns, we're seeing that now in this area model. We're looking at the space that's being taken up. This is 3/5, right? You can see 1, 2, 3, horizontally all the way across, or maybe you see it as 1, 2, 3 by 1, 2, 3, 4, right? Maybe you see it as 12/20. And likewise here, right? 12/20. And here, right, what we've been talking about is why is it so important to understand these equivalent fractions, right? 3 times 4 is 12, 5 times 4 is 20. We see that equivalence in this space right here. And then same here, 3/4, right? We can think about it as 3/4 times 1 numerically, or we can see this space as 1, 2, 3 columns out of 4 columns, or now we can count all these little pieces. This would be 15/20. And now we can add up all of these pieces, right? We have 2 wholes plus 12 plus 12 plus 9 plus 15/20. Add them all together. And I'm going to let you, and I think this shows, let me see this. I just want to, oh yeah. Or you can think about it as, right, where the algorithm comes from. You can create fractions greater than 1, multiply across, right? Multiply the numerators, multiply the denominators, and then, I don't know why it's all kind of off here. And then you can simplify 4 8/20, 4 2/5. If we added all of these together, right, 12 plus 12 plus 9 plus 15, we would you know, have even and or what the only thing I don't like about this is limiting. We can take all of these if we drew this on a paper and then so here's our 9/20ths. We can use this. Let me see if I get it like a gray, a light green. This is the closest I got, right? If I take these 9/20ths, I'll cross these out and I'll color in 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to take these 15. Well, 1, 2, 3, 4, 5, 6, 7. So I'm going to take out 7 of these. 3, 6, 7. So take away all of those. I'll probably do this in white. So what we have left are these 1, 2, 3, 4, 5, 6, 7, 8, right? Take out all of this and I have, right, 1 hole, 2 holes, 3 holes, 4 holes, and then these 8/20ths here. So you can rearrange, right? This is an area model. So you find the total area through this multiplication, but then you can rearrange it, right? Without changing the area, rearrange it, bring these, this space, put it up there. So I can fill in this hole up here, this hole up here to get 4, 4 ones, 4 holes. And then we'll have these 1, 2, 3, 4, 5, 6, 7, 8 space down there. Sorry, that's really ugly now, but I hope that made sense. So play with this. Change the denominator. Look what happens, right? When I get super big. What if I wanted 11ths, 12ths? Change the numerator. How many, right? How many holes do you want? You can see it increasing here. We have over 2 holes, almost 3 holes. Change the numerator and denominator down here. All right, the denominator is looking, it's making the pieces smaller. The numerator is saying, I want more of those pieces, right? This is the same exact relationship that we've been talking about. And now you can see this multiplication as this area, right? We want all of this space because we see what's happening here with these mixed numbers. So play with it, practice your explanations, practice making these connections.